Today we're discussing concrete freeze-thaw damage explained, the key factors and what to consider. First, concrete freeze-thaw damage explained, water enters pores freezes expands 9% breaks concrete. Air-entrained concrete prevents this. Next, the silent killer of outdoor concrete. In regions like North Carolina, the freeze-thaw cycle is the single greatest enemy of your driveway and patio. It is a slow, mechanical process that can turn a high-quality slab into a crumbling mess in just a few seasons. If you've ever seen the top layer of concrete peeling off in sheets, you've seen freeze-thaw damage in action. Here is the science of why it happens and how to prevent it. Regarding the 9% expansion rule, concrete is naturally porous. It's filled with billions of microscopic tunnels and air pockets. When it rains, water enters these pores. When the temperature drops below freezing, that trapped water turns into ice. As water freezes, it expands by approximately 9% in volume. Because concrete is a rigid material, it has no give. That 9% expansion creates thousands of pounds of internal pressure, literally pushing the concrete apart from the inside out. On the result, scaling and spalling. The first sign of freeze-thaw damage is scaling, tiny flakes of the surface peeling off. As the cycle repeats, freezing at night, thawing during the day, the damage goes deeper. Eventually, larger chunks of the surface break away, spalling, exposing the rocks, aggregate, underneath. Once the aggregate is exposed, the concrete absorbs even more water, and the destruction accelerates. Moving to the solution number 1, air entrainment, the micro bumper. This is a secret that high-end contractors like local Concrete Contractor always use. We use concrete with an air entraining admixture. This chemical creates billions of microscopic air bubbles, about 5 to 7% of the total volume, throughout the slab. These bubbles act like tiny shock absorbers. When water freezes and expands, it has a place to go. It pushes into the tiny air bubble instead of pushing against the concrete. This prevents the internal pressure from ever reaching the breaking point. Next, the solution number 2, low porosity, 4000 psi. The best way to stop freeze-thaw damage is to stop water from entering the slab in the first place. As we've discussed in other articles, 4000 psi concrete is much denser than standard residential 3000 psi mix. Fewer tunnels mean less water, which means less expansion. For more information or to request a free estimate, visit localconcretecontractor.com.